All right, guys, welcome back to the shack. And if you've ever wanted to make these kind of signs like this, and you thought that a laser was the only way that you could produce these signs, then you were mistaken. And so was I. Recently, I bought some material a couple years ago for lasers. This stuff here is 2-layered plastic. It's got a color on the outside and then a white core. And I bought it for lasers. It did not work with the lasers really well, and so I just threw it to the side until this week, and I got it out and started using it. And guys, there's some pretty cool project ideas that can be made with this stuff and a spindle CNC, like the Shapeoko, the Masuda 3S, the 3020. Any spindle CNC, for the most part, should be able to handle this. Depending on the work area, you can just make them smaller or make them bigger, but it doesn't take a powerhouse of a CNC to cut this plastic. So stick around. I'm going to go through how I did it, how I set it up, and give you some of the specifics, and you can try them at home and see what you think about them. So let's get started. So first of all, this material that I got it from Amazon. There are other materials that are similar. There's thicker materials that you can get out there. This is really thin. It's only about 2 millimeters thick, and it's not something that, you know, it's going to be really robust for building. It's made just for signage that you can stick to the wall, or you can put holes in it and put screws through it to hold it in place if you need to. But these are small, like the size of a sheet of paper, and I will drop links down below to where I got this stuff on Amazon if you want to go look at it. But it's turned out to be a pretty cool project idea for the CNCs. So I'm just going to set this to the side here for now. And I'll just walk you through a few of the designs that I've did and give you the specifications. So these were done on the 3020 SainSmart. So that's a really small CNC. You don't have to have a lot of power. You don't have to have an overpowered spindle to be able to engrave or cut this stuff. You're only going, the deepest that I went was 0.4 millimeters, and the shallowest was 0.3. Anything less than 0.3, and there was some spots to where it wasn't getting rid of all of the color. So I wound up going with between 0.3 and 0.4 millimeters depth. You can go down to, and I did a couple of them, all the way down to 0.5 millimeter, but you start getting kind of thin and it could cause it to break when you get, because you're at about probably 1/3 of the depth of the material. So there's really no need in going that deep. But the 0.3, 0.4 works fine. So the two tool paths that I use for this basically is just going to be a profile for the cut, and then of course a pocket for the lettering. And like I said, the speeds and feeds on this, you don't have to have a big bulky spindle. All right, so I'll show you the bits that I use to do the cutting with first. We'll go ahead and get that out of the way, because a lot of you guys are going to want to know what bits to use depending on which machine you have. There's a variety of bits that you could use. Of course, when you're trying to do something that has these little sharp corners and these fine details, the sharper, the smaller the point of the engrave, the better you can do with those. Because if your bit's bigger than that part of the engrave, then the software is just going to skip it. So I went through using some V-bits. I tried using some standard upcut bits, and the results that I like as far as being able to do everything with one bit to keep it simple, so far I am loving tapered ball nose bits. For the 3020 from SainSmart, I used this bit here. This is a Speed Tools bit, and you can get them on Amazon. I'll drop links down below. They're not all that expensive, and they do a pretty good job. Now, they're not, you know, going to be a really like premium bit, but for the smaller machines, especially in the 3 millimeter, 1/8 inch bit size, they do a really good job. This one is a 0.5 millimeter tip, and so that gives me the ability to do some really intricate, fine detail with this bit here. Like I said, keep in mind the size of the tip is going to determine how sharp of a corner you can make and how small of an object you can engrave. So if you're wanting to cut this out, or if you're wanting to cut out, let's say acrylic, plexiglass, polycarbonate, whatever you want to call it, any of that stuff that you're wanting to cut, you're going to also want to use an O-flute bit for cutting. You can use other bits, and I did in some of these projects, but an O-flute is a really effective way of cutting these acrylics and plastics. The thing that you don't want to do is run the RPMs up really, really high, and we'll go over that as well, because that can cause melting and just make the engraved look bad. You want a good clean cut. So the O-flute, this is an O-flute from Genie Bits from my buddy Cody over at Cadence Manufacturing. I'll drop a link to his as well. These are great for cutting. I asked Cody about doing a smaller Genie bit. He does have a tapered ball nose, so if you're doing a bigger sign, but it only goes down to 1/16 of an inch as far as the tip size goes. So you can use the skinny Genie to do these, but like I said, that tip is going to limit you ever so slightly. The other bit that I use for my big machine here, this is another Speed Tools bit that I picked up, and this bit right here is a 1/4 inch tapered ball nose. This one has a 1/32 tip, which is still really, really small. But that gives me the ability to go into the smaller places as well. So if you were doing like big shapes and you didn't really care about the sharp corners, you could use any tapered ball nose or even just a standard ball nose if you wanted to, as long as the tip was big enough. I like the tapered ball noses because it's a more robust, sturdier bit, but you can use it to engrave, and you can cut with these as well. You're just going to have to do multiple passes, and each time you go around, it's going to get a little deeper and a little deeper. And with the tapered ball nose, it's going to kind of have that edge is going to not be completely square. It'll be kind of at an angle, and so that makes a pretty good cut. You can see on, like, say this one, I actually cut this one out with a tapered ball nose. It's really not that easy to tell because the angle, I think it's like a 15-degree angle, so it's really not that noticeable, but it does keep those little sharp edges down a little bit. Depending on the type of bed that you have on your machine. If you have, like with this machine here, I have this hybrid bed that has the T-tracks and the bed. With this thin material here, it will bend relatively easy. So what I would advise you, if you have a machine like mine, is get yourself a small piece of MDF or some type of material and put underneath the plastic so that as the bit goes across there, it doesn't punch a hole through the material or bend the material as it's going through. You can see I use this one to cut a lot of these signs out. And all I do is just clamp this onto the work area and onto the bed of the machine, and then I used the old trusty CA glue and tape approach to hold the plastic to this piece of MDF. And it worked out really well. And then once you get ready to get it up, of course, I just use this old chisel right here as kind of a pry tool to get under there and pop those things up. One thing that I did learn with this material is dust collection kind of works with it. But the little particles that come off of there, of course, they get charged with static electricity, and so they stick to everything. It's like dust almost, because the little chips are so tiny, but they're charged to the point to where they'll like magnetically stick to almost any surface. The one thing that I have found is having a little paintbrush or something around to kind of sweep those guys into a pile and hit them with a shop vac is helpful. And if you have if you do these, and let's say when you get done, like with this one right here, you know, you say you got some little pieces that are inside that engrave. I went to Dollar General, got myself this little dish scrubbing brush right here, and it works really good at getting in there and kind of pulling those guys out of those holes because, like I said, that static electricity will hold them down in there, and it makes them really hard to get out. You can also use compressed air. It gets it off pretty well. Also, all in all, the process is not that difficult, guys. There's a couple of things that I did learn through my testing, and I'm still going to keep playing with these things, but I've been doing a lot of them. And I've got a pretty good concept of how to do it. The one thing that I will tell you is if you're using, regardless of what bit you're using, if you're using a ball nose, like a tapered ball nose, you're going to want to run 3D finishing step over with this stuff. If you get above, let's say above 20% step over, once you start getting too far into the step over, it seems like it makes it a little easier to see the lines in the material. And what you don't want to happen is to have those lines. For some reason, with some of the ones that I was experimenting with on my big machine, you can see that I got a little bit, and it is really hard to see on the camera, but there's a little bit of lines in that one. And I don't know if it was just in the program, a glitch in the system, or what. The rest of them done pretty well, but occasionally you will see some lines. The way that I've been able to get around that and eliminate that mostly has been to just run really high step over and make sure that the material is securely fastened down. And you don't want it moving around and wiggling on the spool board. So make sure you don't go stingy with the tape and everything on there. All right, guys, so I just thought this was a cool project idea. It was something that you don't see a whole lot of. And this pack of this plastic, I think it was like 25 bucks. And so if I were to try to take this stuff and make these signs out of it, for 25 bucks, I could probably make my money back pretty quick with a little, small signs for people to sit on their desk, or, like lockers or something like that. My wife even mentioned kids' bike tags, like little tags for kids' bikes. If you wanted to do like some simulated, some tags, replicas and stuff like that, maybe like some little decorative type tags, you could do that. This stuff could be used for countless things, and it's just really cool. Like I said, it's not as noxious as, say, trying to cut this stuff with a laser. It was advertised as being laserable, but I just never could get any good results, and I was a little concerned with the smoke and the fumes from it. But doing it with a CNC, of course, you're just more or less cutting it with a saw, so that wasn't really an issue. One thing that I will add too is I used my bandsaw to cut this stuff down and make it smaller for the 30-20, and it cuts really good with a high tooth count blade. So you could cut it with, you can cut it with a utility knife if you needed to by scoring it and snapping it. You can cut it with a table saw, as long as you have a fine enough tooth count, as well as scroll saw, jigsaw, or bandsaw. So it's a really versatile material. So if you don't have a laser and you want to do these kind of signs made out of plastic, I think this is a good option for you. So let me know down in the comments what you think about it, and if you have any plans on doing them, or think of another way that you could use this material to turn a little bit of profit for your machines. Let me know. All right, guys, so that's going to wrap it up for tonight, and that's all I know to say about that. I haven't mastered the speeds and feeds. Everybody's machine is going to be a little bit different. So you can take the settings that I've given you and kind of go from there and kind of use it as a jump off to try to dial things in. I'll try to make sure to put those screenshots up here again in case everyone wants to see it. I've got the screenshot of the 1/8 inch bit with all the speeds and feeds right there, as well as the 1/4 inch bit that I used, speeds and feeds. Of course, as with anything, guys, your machine may not be 100% the way that mine is. So do some testing, play around with it, and figure out what works for you. And if you ever find yourself looking for somewhere to come hang out on Sunday afternoons, be sure to check out myself and Steve over at Vintage's Workshop. We do a live every Sunday night. We've been doing it for a couple of years now. It's basically a Q&A, social gathering, just hanging out, talking about lasers, 3D printers, CNCs, whatever topics you guys bring up, whether it be business management, we don't care. We're just there. We'll give you about 2 hours of our time, and we're going to blast through the questions and try to help you guys learn to enjoy, have fun, and make money with the machines. So be sure to put that on your calendar and come check us out, 7 o'clock p.m. Central. My channel or Steve's over at Vintage's Workshop every Sunday night. So see you then. But until next time, guys, be safe and have a good day.